Okay, so let's start with the given. In the problem, it said that there was an electromotive force of E with the value of 100 sine 10t. Also, there was a coil that had a 0.1 Henry inductance and a 10 ohm resistance. From the problem, it said that at time 0, there was a current of 0.995 amperes. So we're done with the given. Solving the equation, the problem. The first question was get the current as a function of time. So here we have Kirchhoff's law. And we just substitute the terms from the given to Kirchhoff's law. 100 sine 10t equals 0.1 di over dt plus 10i. Now we solve it by the use of linear equations of order 1. So at first we remove 0.1, the decimal, because it's harder to solve with that there. So you multiply everything by 10. Now let's start with the solving of the linear equations of order 1. When using that method, you have to use this equation where Vy equals integral of V r of x dx, wherein V equals 100 e raised to 100t and r of x equals 1000 sine 10t. When substituting those terms, you get this. E raised to 100t times I equals 1000 integral of 100 e raised to 100t sine 10t dt. Now, you can't solve this by the normal integration alone. So you have to solve this by integration by parts. So you use the equation uv minus integral of v du. So you get this. 1 over 100 sine 10t e raised to 100t minus 1 over 10 integral of e 100t cosine 10t dt. Now, that's another equation that can be solved by integration by parts. So you do it again. U equals 1 over 100 sine 10t times e raised to 100t minus 1 over 10 times 1 over 100. This is the part where you use the second integration by parts. Wherein 1 over 100 cosine 10t e raised to 100t plus 1 over 10 integral of. After that, you simplify everything, try to eliminate all unnecessary unnecessary constants, and you get this equation. I equals 2000 over 201 sine 10t minus 200 over 201 cosine 10t. After doing that, you have to solve for C. By solving for C, you use the initial conditions that at time 0, the current is negative 0.995 amperes, whereas approximately 200 over 201, negative 200 over 201. Now you substitute the terms, you get negative 200 over 201 equals negative 200 over 201 cosine 0 plus C e raised to negative 100 times 0, this just gives 1, wherein you get C equals 0. Then you get the answer for letter A, wherein I equals 2000 over 201 sine 10t minus 200 over 201 cosine 10t.
So for letter B, you're looking for the current at t is equal to 0.1 seconds. So you just plug it in, then you'll get the value of 7.835 amperes. So for letter C, to compute for time when current reaches a maximum, you do the first derivative. So di over dt then equate to 0. So di over dt is equal to 2000 times 10 over 201 cosine 10t plus 200 times 10 over 201 sine 10t, then equate it to 0. Then using shift solve, you'll get the value for t is equal to 0.1581 seconds. Maximum current, substitute the time in D to the equation in letter A. Then you'll get the value of 9.96 amperes.